Welcome to the second part of our video on quality metrics of OSCE, prepared by Clinical Skills Assessment team. It's time now for our third evaluation question, the question of fairness. Were all students subjected to equivalent examination conditions? We measure that by using the between group variance. So, if we're an OSCE exam, there are factors that might affect the scores of the students. First, there is the performance of the student in the exam. And then we have some circuit variations that might affect the performance of the students, like variation in equipments, variation in the layout, in the simulated patient, or in the assessor. Ideally, all the marks variation should be due to the difference in the student performance alone, given that the students are randomly allocated to the circuits. Before we begin our analysis, the special groups, if we have a special group that was aggregated in a circuit, should be cancelled from the analysis. And we have to make sure that the circuit layout, the simulated patients, and the equipments are standardized across the circuits. Between group variance is measured by one-way analysis of variance, or ANOVA. Here we have station 1 and the scores of station 1 across 4 different circuits. And using ANOVA, which is a simple, straightforward function in Excel or in any other statistics software, we measure the between group variance. And here we notice that all the between group variance here regarding station 1, station 2, station 3, and station 4 are calculated. And we notice here that in station 4, it is 50%. It means that there is a variation between the different circuits that reaches up to 50% in station 4. So is this acceptable? No. A variation of more than 40%, it denotes that there's a potential inconsistent assessor behavior and or other circuit-specific problems. So it's either the Hauser-Dove examiner effects, or it can mean that there is a problem in the circuit itself. Other factors to consider in an OSCE exam quality measurement is the number of failures. And increasing the number of failures in certain stations can mean that there is deficient teaching in this part, or there's a faulty standard setting, there's unclear instructions, or there's a poor performance of simulated patients. It can also mean that there's a misalignment between the exam and the ILOs. Further quality metrics can be applied if we're using a standard setting tool. The coefficient of determination is a very helpful metric that we can use. It is simply a correlation between the checklist score and the global rating score. The global rating score is the one given by the assessor to give a general idea about his, it is a bit subjective, but it is his or her view on the performance of the candidate as a whole, in a holistic manner. So, while the total score is just the checklist score. A good correlation should be more than 0.5. So let's do this practically. This is the checklist score ascending, and this is the global rating score. And then we're going to put the students' marks here and here. So in this case, this is a good correlation, means that the students that performed poorly in the checklist score also performed poorly in the global rating score, and the same goes for the student who performed excellently. A poor correlation, which is less than 0.5, means that, contrary to the other example, here we can see that some of the students performed rather well on the checklist score, but failed on the global rating score. Also, there's a wide distribution of the students' marks across the checklist score. Same goes for excellent. Here we can see that some of the students were scored excellent in the global rating score, however, they performed poorly in the checklist score. So what is the cause of the poor correlation here? It could be a poor checklist design, a mismatch between the checklists and the ILOs understood by the assessors. Let's not forget that we need also to take the feedback from the students, the examiners, and the simulated patients at the end of the OSCE exam. And we need to remind ourselves all the time that we cannot use a single metric to determine whether this OSCE is of high quality or not, because no single metric is sufficient alone. We need to have a 360 degrees view of the OSCE exam, including all the metrics discussed before. So what is the next step? How do we use these results in order to improve our exam? We can adjust the total marks for side effects. We can also adjust to a common mean across all sides. And we might need to remove a station. However, this is very rare. And we can use this only if there are multiple adverse metrics that affect actually the student marks drastically. So how to avoid this? Of course, this can be a very hectic procedure and very complicated one. So it is better to avoid it. So we avoid it by upgrading the training methods for the examiners and for the simulating patients, improving the assessor briefing to avoid any misunderstanding, improving the simulated patients' briefings, giving a detailed assessor support material also to avoid any confusion, and using dummy runs, which is extremely important. Thank you.